moving on. And so this is now this combined law thing. What is this combined law? So when we were talking, let me back up here and talk about some of our other gas laws, right? Like Amenton's law, P1 over T1 equals P2 over T2. This is with constant volume in moles, right? Or Charles' law, V1 over T1 equals V2 over T2. This is with constant pressure. Or now, Boyle's law, P1 V1 equals P2 V2, and this is with constant temperature. But what if none of those things were constant, right? What if I wanted to think about how all of those things can change? Well, now here's my combined law, all right, where I've combined namely Boyle's law and Charles' law. P1 times V1 divided by T1 equals P2 times V2 divided by T2. And here I'm actually going to place 1 with room and 2 with STP. And so what we can actually do with this, so I talked about that STP number, right? Okay, well, we can use this to kind of easily correct for what that should be. Because rarely, so remember what STP means, 1 atmosphere and 273 Kelvin, which is 0 degrees. So that's like a big giant meat locker, like a big giant walk-in refrigerator. We don't do chemistry in a big giant walk-in refrigerator. You would be very cold if you did that. So that's why I replaced the 1s here with room, because we do chemistry like in a room, right? That's typically 25 degrees Celsius or 298 Kelvin, not 0 degrees Celsius, okay? So in this problem, suppose we measure the volume of 1 mole of a gas to be 35.42 milliliters at a typical room condition, which is 295 K and 0.987 atmospheres. What is the volume of this gas in STP conditions? Okay, so this is pretty typical, right? Where we would have measurements at room conditions, but now we want to scale that up to STP conditions. So let's see how that would all manifest, okay? So now let's see here. So I know, so it's asking me what is the volume of this gas in STP conditions? Okay, so we're going to solve for that VSTP. VSTP, okay? And what I realize is I don't think that this could be 1 mole of a gas, right? That would not be correct, because 1 mole of a gas would have to occupy like 22 liters. So I'm going to say, suppose we measure the volume of some amount. Okay, so I wrote that question incorrectly. So we measure the volume of some amount of an ideal gas to be 35.42 mils. Okay, so we're solving for VSTP, and I'm just going to quickly do the algebra here and write that's now T STP. Oh, I can't write. Okay, so just to tell you really quick what I'm doing, I'm going to multiply both sides by T over P. So I'm going to multiply this by T. I keep writing, I'm writing like S, and I can't say T while I write S for some reason. T STP divided by P STP, right? I'm going to multiply both sides of the equation by that factor to isolate the units that I want, okay? So now this gives me VSTP equals T STP times P room times room V room, okay, divided by P STP times temperature of the room. And now all we got to do is plug in what we know. So we know TSTP is 273.15 Kelvin, okay? So I'm going to put that in there, 273.15 Kelvin with all the digits to get an accurate answer. So P room, they tell me the pressure of the room is 0.987 atmospheres, not exactly 1. And rarely, very rarely, even at sea level, here in Humboldt County, very rarely is the pressure actually ever 1.00 atmospheres, right? So that's why this is useful to be able to correct to what the actual standard temperature pressure condition is. Okay? And then they measure the volume to be 35.42 milliliters. And this is a situation where I can just leave it in 35.42 milliliters because I don't have the ideal gas constant in this equation. So I can leave it in this milliliters, and the answer it's going to give me is in milliliters. Okay, PSTP we know is, right, exactly, I mean, I could write 8 million zeros. It's one atmosphere, 1.000000, whatever, okay? And then temperature of the room we measure to be 295 Kelvin, okay? And I'm going to use four sig figs. I probably should have had one more sig fig. I'll just cheat and I'll say 0.9870, and I'll call that 295.0. And I want to make that many sig figs to illustrate how different this volume becomes. Okay. So 273.15. So the sig figs there are because I didn't write the question very well, not because I'm like cheating the sig fig rules. Okay. So 273.15 times 0.987 times 35.42, okay, divide by 1, and then divide by 295 equals, aha, and now I get 32.37 milliliters. So that's why I knew that there's no way that could be 1 mole, because 1 mole should occupy 22.4 liters, not 32.37 milliliters. So this would be much less than 1 mole of a gas. But all the same, as you can see, when we do chemistry, we're not ever doing chemistry at these STP conditions, right? It's impossible. So use of the combined law is a way of either correcting the STP conditions to the room conditions or vice versa, correcting the room conditions to the STP conditions. It goes either way because of this proportionality. Okay?